This video covers other parts of Tidyverse, including mutating. So the mutate function is used to make a new column. So within econometrics, we often like to create a dummy variable. A dummy variable, for instance, for gender, would take the value of 1 for female and 0 for male. So let's look within the nest data, the variable gender, and you see that we have male or female. We can convert this into a 1 and 0, and the first thing we're doing is we're resaving the data. So in this case I say nest equal nest. That basically means store the existing data with the additional column into nest. So we're updating the data in a way. And we're going to use mutate. This is the name of the new variable. And then the condition, we use if else, and it says if gender, remember, equal is female, then we're going to assign a 1. We can look at the output of this new variable we created, and it happens to match exactly the same as what we did when we just look at gender, but gender has 2 factors, male or female, whereas now female is a dummy variable that has 0 or 1. Next function we're going to look at is summarise, which is used to create new summary variables. So for example, we can find the maximum lot size within the Brazilian data. So we have here Brazil, and we're going to use summarise, and we're going to call the max. This is the name of the new variable, or where we're going to store it. Think about it like we're going to store whatever we find there, and then we use the function we learned before, max. We look, lot size is the column within the Brazilian data, and then as always we remove any missing information, and we get the max is 3,146. We can check that by arranging our data set. So we can arrange the Brazilian data set by lot size, and we can make it in descending order. We can add the minus to get descending. We can select only lot size as the column, and we can look at the first observation, and it happens to match. They are exactly the same. What about if we look at the max lot size per municipality? So we can definitely do that if we combine the group by and summarize. So we're combining 2. We first group by municipality, then we're gonna also store it under the name max lot size, just like we did before. So nothing changes really. This line is exactly the same as this line. The only difference is that we're grouping by municipality. And what we get is that the max, it varies per municipality, but we get that for Archimedes, that's where the max is 3,146. But if we go down and we see Sao Felipe is only 67.8. So just so that you know that. We can look at the mean within each municipality. So the only thing I'm changing now in the code is the function that we're using. Instead of using max, I'm now using mean, and I'm changing the name of the variable that's going to store that. And then we see that we have different numbers here. So again, Archimedes is 137, but then if we go down to Sao Felipe is 36. The next item I want to show you is counting. The function count is used to create counts by groups. So again, keeping the same idea of using the data from Brazil and grouping by municipality, we can count how many observations we have per municipality. So we have 79 that are NAs. This matches our previous video, but we know we have some missing observations within this Brazilian data. But then we have different counts per municipality. So Archimedes has 148. Then we have, let's say, Montenegro, 133. Let me show the same information when I run it within R. So if I run, we can see here the table, and we see the number, the counts we have per municipality. So that's another way of viewing things. So anything I'm running, you can definitely run within your R script. The other item I want to cover is proportions. So this is back to the previous video that I made when we used table and then divided by n row. We're going to do the same, but now using Tidyverse and the pipe. So for proportions, the idea here is we're going to combine summarise, mutate, and group by to get us the proportion of observations we have per municipality. We're going to have to use a new function called ungroup before we mutate. So first line is our data, then we're going to group by municipality. We've done this before. We use the count, then we ungroup, and once we ungroup, we're going to do the mutate, and we're going to create a new variable called prop, but you can call it proportion or whatever you want, and we're just going to do n over the sum of n. We get the count, and we get the proportion, and we find that the proportion is 10%, let's say for Arquimes. Then we go down, we have roughly 7% for the following one. For Mirante de Serra, we have roughly 6%, and so on. We could achieve the same by just doing table Brazil $ municipality over NRO Brazil. We could have done here NRO and remove the NAs, but it hasn't done it when we do it here. It still looks at those that are empty. So to have the same output, we don't include which is exclamation point is NA. And if we look at the answers, this number matches, it is rounded, but we're getting the same numbers from both. So the question for you guys is, which one do you prefer? The last item for this part of the video is about missing data. As a researcher, as an economist that is working with data, you always want to try to understand your data first. And one of the first steps you want to do is to know if you have missing observations. And missing observations could happen for a variety of reasons. There could be, if you give a survey, people may skip that question, so you're going to get missing observations for that particular question for that individual. Or it could be that there was some issue with the way the data was collected, something along those lines. But you definitely want to be aware of this. In ICA 1, you found missing data using which, and is .NA. The code lines from ICA 1 are pretty straightforward. So we're looking at the rows that have NAs for fossil fuel, and then we're looking at how many rows we have for that, and we know that is 69. We can do the same with Tydyverse, and we can do data, select fossil fuels, and then summarize, and we can use a function, sum is NA, and we get the same output. So you see that 69 is in both. We can run it in R. So we did already the proportions. Let me show you just for completeness. You see here the table, and it's the same information, is just displayed differently. And then when we go to missing data, this is what we did before, 69, and then we can run alternatively this one, which gives us also 69.